Good morning, this is Mrs. Doris, and we're beginning Chapter 3 today with Lesson 1, Inequalities and Their Graphs. Our objective today is that you will be able to write, graph, and identify solutions of inequalities. And the reason that we study inequalities is because we do have some quantities that have a relationship that is not equal. Vocabulary in this lesson is, first of all, inequality, and that is simply a mathematical sentence that compares two expressions that are not equal. A solution of an inequality is any number that makes the inequality true. All right, a little background, and I'm sure that many of you have studied inequalities before and may remember this, but I just want to review it with you. First of all, an equation such as x equals 7 has only one solution. It can be graphed on a number line as, and all we do for an equation is we put a dot on the solution. So x equals 7 will have a point at 7. An inequality such as x is greater than 7 are all real numbers greater than 7. That includes fractions, decimals, of course your positive integers and whole numbers, and they can be graphed on a number line in this way. Since it is greater than 7 but not equal to 7, we put an open circle. And then we want to graph all points that are greater than, and I like making nice thick lines so that we can actually see it. And there would be the graph of x is greater than 7. The open circle indicates that it is not equal to 7. The solutions of the inequality x is less than or equal to 7 are all real numbers equal to or, and that should be less than, 7. They can be graphed on a number line in this way. Now, because we have less than or equal to, when I put my dot at 7, this time it's not going to be an open circle. This indicates that it includes 7 as well. And then in this example, it's everything less than 7 or equal to it. So again, I'm going to make a nice big fat line to show all the numbers that are less than or equal to 7. All right, so we're going to get right to the problems and see the type that you'll have to solve in this lesson. Problem 1 is writing inequalities. What is an inequality that represents the verbal expression? Our first one is all real numbers p greater than or equal to 1.1. The words greater than or equal to indicate this symbol, and we want numbers greater than 1.5. So p is greater than or equal to 1.5. The next example, the sum, all right, that indicates I'm going to have an addition sentence. The sum of t and 7. All right, so we're going to add t plus 7 is less than negative 3. So there is our less than symbol and negative 3 on the right side. The next example, the difference of 8 and x. Difference indicates subtraction, so we have 8 minus x is less than or equal to, so we put the line under the less than sign to indicate it could be equal to 4. And our last example, the product, which indicates multiplication, the product of 9 and m. Now remember, when we write a product and we've got a number and a variable, we don't show any multiplication symbol between them. And the 9 always has to come first. So even if this said the product of m and 9, we would still write 9m. Is greater than 3. Problem 2, identifying solutions by evaluating. Consider the numbers -1, 0, 1, and 3, which are solutions of the mathematical sentence 13 minus 7y is less than 6. All right, so we're going to begin. We'll start with -1, and I'm going to rewrite my inequality, and where I see the y, I'm going to put in -1. And we're going to evaluate it. 13, I have to multiply first before I subtract, so I have 13 minus, or I'll tell you what let's do. Let's change our subtraction to adding the opposite, and then that'll make it a little bit easier, and we won't be so inclined to get the wrong sign. -7 times -1 is +7, so we have 13 plus 7 is less than 6. 13 plus 7 is 20. 20 is not less than 6, so -1 would not be a solution. So right now I'm going to say no. Let's do the next one. We're going to do 0. All right, so I have 13 minus 7 times 0 is less than 6. All right, this is 1. 7 times 0 is, of course, 0. So I have 13 minus 0, which is 13, which is less than 6. And again, this would not be a solution. Okay, let's take 1. All right, so I have 13 minus 7 times 1 is less than 6. 7 times 1 is 7. 13 minus 7 is 6. 6 is not less than 6. So again, I would have to say no. This is not a solution. And finally, we're going to check out the 3. All right, so we have 13 minus 7 times 3. And our question is that less than 6? All right, so evaluating, and again, we multiply using the order of operations before we subtract. 7 times 3 is 21. 13 minus 21 would be -8. Is -8 less than 6? And our answer to this, of course, would be yes. So our only solution is 3. And I'm going to write a statement to that effect. 3 is the only number given that is a solution. All right, and we could also say -1, 0, and 1 are not solutions. Okay, problem 3, you're going to be asked to graph some inequalities. So our first one that we're going to graph is x is greater than -4. All right, first of all, looking at my number, -4, I know that I'm going to start right here. I am making my circle open because of the symbol greater than. It is not equal to 4, but greater than 4. Greater than means that we go to the right. All the numbers that are greater than -4 will be all these numbers right here. And then we'll put an arrow on it to show that that continues to infinity. All right? So there's an infinite number of numbers that are greater than -4. Our next example, c is less than 0. And I don't have any numbers on here, so I'm going to put my 0 right here. It also helps just to label at least, I like to label at least 3 numbers, one on either side of where I'm putting my point. C is less than 0, it's not equal to, so again I'm going to have an open circle. And this time we want every number that is less than. So that will be all of these negative numbers going in this direction. And again, we'll put an arrow on it to show that it is continuing forever. All right, now the last one is written in kind of a different form. You'll notice that in this case, the variable is on the right-hand side, whereas in the other two examples, the variable was on the left. The nice thing about having the variable on the left is you see the inequality symbol points in the same direction that my arrow points. Likewise, c is less than 0. The less than symbol is pointing to the left, and so is my graph pointing to the left. My suggestion on this one is to rewrite the expression 3 is less than n. To do that, to put n on the left, notice that you have to switch the inequality symbol to point the other direction. So rather than 3 is less than n, we want to write n is greater than 3. And that represents the same expression. Another way to do this is simply to start substituting in numbers. Think about 3 is less than what numbers? Well, it's less than 4. 3 is less than 5. So what that tells me, at 3, I want to have an open circle. Again, it's not equal to. And then I want to include these numbers 4 and 5, which are right here. All right, so my line is going to go this direction. And that would be another way of thinking about it if you don't rewrite the inequality. If you rewrite the inequality, then your arrow is going to go in the same direction as the symbol. All right, your practice problems today are on page 168, and I'd like you to do 9 through 41, the odds. If you have any questions, please ask me during class or come in and see me. Thank you very much.